So, hello everyone, welcome. We now going to discuss why or how the physical systems will be converted into physical as well as mathematical model. Now, what are the steps? Now, the physical systems that we are going to consider now is mechanical systems. Okay? And we know that mechanical systems can be of two types: translational. Mechanical systems may have a translational motion or rotational motion. Depending upon that, we will take two types of system. One is translational system, another one is rotational system. Now, why I am telling you that? Because the systems which we are going to discuss in this lecture is basically should have system having motion but having static motion, but after that it should reach in static equilibrium. That is what type of system. Actually, we would like to discuss that type of systems. So, like suppose a spring, mass and damper. Suppose I have a system with a mass of m, and it is attached to this wall with a spring or with a wire. Now, what will happen? What will happen if I push this system, pull this system in this direction? There will be certain amount of motion initially imparted within this system, this mass, and afterwards it will again be at static equilibrium. That means that motion will be gone, and after time of applying force, you will find that the mass is at rest. Or suppose same system, it will be probably make you imagine easier that if I have a system like this, it is attached with a string. We know any string is having a certain amount of elasticity that I am expressing with this factor of elasticity. So this is a mass, and I am pulling this in this way with a force, and after applying the force, as this mass is attached, there is a motion. Initially there is a motion depending upon the force, but afterwards this motion initially it will oscillate. This mass will oscillate up and down, and afterwards, after a certain time, this force will be definitely opposed by certain forces, and afterwards after few seconds or few minutes, you will find that the mass is again at rest. Okay. Initially it was rest, you have pulled it with a force, there is a oscillation within the system, and afterwards the oscillation is damped, and you will find the mass is again is at rest, and it is hovering from the wall, or it is attached from the wall in this way, but it is at rest. Now, we are going to consider this type of systems or mechanical systems, and this type of motions we will call them as translational motions. That is, they are having a to and fro, up and down motion. So it's a translational motion of a mass. But if you think in this motion, suppose I have a motor, it is rotating in this direction, so it should have a rotational motion. So motion, depending upon the motion, we have divided the mechanical systems in two types. One is translational system and another one is rotational system. Okay, and we are going to discuss this type of system in our lectures, and we are going to learn how to model this type of systems. Now, as we have told, we have discussed earlier that we will consider different physical quantities acting on the system, and we will know the relation of them, and we will write them in form of equation, in mathematical equation, and that's or in form of differential equation to describe the system. So how we used to describe the system, let us know that. Now for this type of system, we will follow the Newton's second law, or the law of motion, because you know that here we deals with the force, mass and the acceleration. Okay. Now we have and what is it now? This is algebraic sum of all the forces acting on a rigid body in a given direction is equal to the product of the mass of body and its acceleration in the same direction. Why we are taking this? Because in this equation we can able to express the relation of the mass and the force along with acceleration. We can write this acceleration in form of derivative of velocity with respect to time, or we can able to consider this with respect to position and time. So that means this is the equation for any physical translational systems or even rotational systems. We can get the Newton's law of motion or the second law, and we will take the forces, all the forces which is acting on the mass it will be equal to the mass and the acceleration of that body. Okay, so these law we are going to discuss in our following physical models to get the mathematical model. Understood?